Good morning, everyone, and welcome to this session, DevOps for Machine Learning. I hope you had a good conference so far. I think I'm the third session. For me, I'm Henk Boelman, and I'm a cloud advocate at Microsoft, and I am based in the Netherlands. So for me, it is already end of the day. And of course, when I submitted, I was hoping actually to come to you and speak to you in person, but that turned out a little bit different. So as I said, I'm a cloud advocate at Microsoft specializing in AI. And my job is mainly to help you get started with our Azure AI platform and take your feedback back to the product team so we can make our products more awesome and more suited to your needs. So today I want to talk to you about how you can apply DevOps practices doing machine learning projects. And that becomes especially handy if you're starting to work in a larger team and machine learning models are becoming more integrated in your software solutions. So what are we going to cover today? I think we have around an hour. So we have a lot of things to talk about. So first we're going to look at the components that are available on Microsoft Azure concerning machine learning. Then we're going to dive in the data science process and especially look at what roles there are to play when you're creating a solution. And then we're going to build a machine learning pipeline to illustrate how all these different people within a team can work together on creating a repeatable process for a machine learning model. If you have any questions, please throw them in the chat. And if you see me looking like this, I'm actually looking at the chat. So I will answer your questions right away. So, but first, let's cover what machine learning actually is. So machine learning is to give your computer the ability to learn without explicitly programming it. And in the old days, I wrote a function. I wrote a function, data comes in, I did something, the algorithm, and then an answer went out. And that function I coded, if then, else, for, each, while, this, modulate that, and so on. But now with machine learning, this is switched. So instead of creating the algorithm, we give it a bunch of answers and a bunch of examples. We select the training algorithm, and it will create this algorithm, or in machine learning terms called this model for us. And when we have that model, we can run new data through that model, and we get a prediction out of it. So machine learning on Azure. First, I really like this slide always. It has like these 5 layers which clearly illustrate what kind of levels and tools there are available. So first of all, there is the top layer, and that are our cognitive services. There are around 42 different types of services that can help you solve various problems without having the hassle of actually doing the machine learning part. All these endpoints, these services, are available by API call. So if you want to do vision, see what is on an image, you send your image to an API, and you get the result back in JSON. Same for speech, open a WebSocket, start streaming, translation, send text, and get it back. So you don't have to worry about the AI part. But not all of these services cover your company's need. So then you need to start training your own model. So there are frameworks to do that, like PyTorch, TensorFlow, Keras, Onyx. And if you want to do machine learning on Azure, it doesn't matter which training framework you want. It all runs. But to help you, we have some productivity services, like Azure Databricks, if you have to do large-scale data processing, and Azure Machine Learning, where we're going to dive in a little bit this whole presentation, actually, that can help you facilitate the whole machine learning lifecycle. And there are machine learning virtual machines. So if you want to get started with training your own models, one of these machines is quite handy. It saves you basically setting up this whole environment. And trust me, when you get started, I've done it a few years ago, it takes a lot of time to get your Python environment right, to get your CUDA drivers right, your Jupyter notebooks up and running. So this is all covered on those virtual machines. Large-scale models need a lot of CPU or GPU, depending on the type of your model. And then, of course, you need to deploy them in a repeatable way. So we can give you the model that you can take care of it on-prem, but we can help you deploy it in the cloud. We can use IoT Edge to deploy it to IoT Edge devices. So many options. But today I want to talk about DevOps, and especially AI and DevOps. So I don't know if you know my colleague Donovan Brown. He always says DevOps is the union of people, processes, and products to enable continuous delivery of value to your end users. And actually, that is extremely applicable when you're doing an AI project, because you need people, you definitely need a process for your AI model. Which data is going to go in? How do you train it? How do we know it is actually doing the right thing? And for that, we need products. Because we also, same as software, we want to continuously improve our model to be more accurate, with always our customers at the horizon. So before joining Microsoft, I started working with AI when I was at the consultancy firm. And I have done a lot of software delivery, a lot of DevOps projects. And I was getting pretty relaxed with the whole CI, CD, Azure DevOps, and all the other tools that are out there. It was all working very, very well, and I really understood what everyone's job was. Because I think for one very powerful part of DevOps is that you get to learn what other people do. What do the testers do? What does operation do? What do developers do? What do software architects do? So you can work together as a team. But then this happened. We suddenly got the idea of doing AI. And a data scientist joined our team. And I don't know for you, but for me, that was a completely new area. You always hear it like AI is that magical thing that you just do and put and it works. But if you actually have to do that, it is a little bit different and a little bit weird at the beginning. So I could start from scratch again, because now I had to understand what the data scientist is adding for value and how he or she works, how developers can actually use that thing data scientists make, that AI thing, and then how do you deploy it? How do you run it in production? So I had to level up a little bit and take a look at the data science process. Like, how does it go? What is it? How does it work? And then I learned machine learning can answer questions. And every machine learning journey starts with asking a sharp question. Like, is it this or is it that? How much? What do you want to predict? Is it an anomaly? Which action should I take? So formulate a question. Basically, what you do with when you write a normal function. X goes in, Y goes out, and you ask that function basically a question. So that is also the same with data science. Instead of writing the function, you need data. And I learned that collecting data takes a lot of time. Maybe not the collection part, actually, because most companies are either we don't have data or here you go and good luck with it. So in that case, you need to prepare your data. You need to sort it, you make it clean. Every row has to look the same. You have to check all your images, because if you have wrong images, and we start giving our machine learning training algorithm wrong answers, so wrong input, then it will probably give us wrong output also. So preparing the data takes an extremely long time, and that is what the data scientist focuses the most on it, getting the data ready so the machine can learn from it. Selecting an algorithm can be in many ways. There are tons of algorithms out there, cheat sheets. Train the model. This is the part where what we're actually going to dive into, how we can make that a repeatable process, and then how do you run it in production? Use the answer. So for this demo, we are going to have a look at Azure Machine Learning. We are going to not use the Keras framework. Sorry, my mistake in the slides. we are actually going to use, will this work? Click. Oh, I spoiled that, good. Okay, let's see the animation again. Perfect. We're going to use Azure Machine Learning. We're going to use PyTorch. We're going to use some GPUs, and we're going to deploy it in the cloud. And we're going to answer the question, is it Marge or Homer or which Simpson is it? And for that, we need a dataset. So I happen to have children, and we have a lot of these, yeah, you can do it, Simpson Lego figures. We have 10, like you see on it here, and I've created an open source data set from it. So if you want to play around and redo this demo, you can go here and download this data set and start training it on Simpson's classifier. So this is what we're going to use throughout the presentation. So we have 10 different classes. So let's dive into a way of working, of how we can see people working together. So first, there is the data science discipline. Data scientists work in most likely Jupyter notebooks or Python. Their process, they use their own versioning system, but we're going to introduce Azure Machine Learning. We're going to control Azure Machine Learning with Azure DevOps, and then we're going to deliver a model. So the data scientist is responsible for creating the model that lands in model management. A developer or the development team can check out that model like it would check out a NuGet package. You say, I want a Simpsons model version 3, get it in. You have to write some software around it, and then you can use the model. But you probably have to add a lot more around it. Probably it runs in an API. Has to have some caching, data, logging, whatever you want, because a model alone is never a thing. The model always needs something to run it. So you write software around it. Check that in a different repository, get a build pipeline, building that software, and it can be even a Windows app, but in this case, in this image, it is an Azure. We register this Docker container in an Azure Container Registry. And then if you look from the operations side, actually running machine learning is suddenly not so different anymore. It is a container with probably an API in it, which we can deploy in the same way as that we would deploy any other API. And then our front end, our client, or whatever we're using, can connect to that Kubernetes service where this API is running. So I said it already, Azure Machine Learning Studio or Azure Machine Learning Service is a fully managed cloud service that can help us to build, deploy, and share and work together on machine learning models. So what is it? It is a set of Azure cloud services. So it is not just one thing, it is a set. So it is a container registry, it is a blob storage, it is actually the Azure Machine Learning workspace, and a key vault, and a few more components, application insights. That set of Azure cloud services we can control with a Python SDK or with Azure CLI, and it enables us to prepare, build, and train, manage, track, and deploy models. So it helps us from the data part all the way to running the model in some infrastructure. And to get started, we need to go to 3 phases. We need to prepare our environment so we can work together. Then we have to build our model, experiment, because I highly doubt that you're the first time you're actually right with your model. And by then when we have our model, we need to pick that model up and deploy it. So let's have a look what we have to do when we're preparing our environment. We can do that in multiple ways. We can go to the Azure portal, create a workspace. We can do that in Visual Studio Code, right-click, create an AI workspace. can do that from code in Python using a Python SDK, and you can also do that using the Azure CLI. So creating a workspace in Python looks like this. This illustrates the best how it works. You say workspace create, give a subscription ID, resource group, and location. So the location is very important because later on we will need compute. So we can only use types of virtual machines that are available within that region. So West Europe is always a safe bet. I think in America there are also some data centers close to Seattle that are safe bets, and the ones around New York also. But some other ones that are the GPU machines are not available. So first have a look if that is available in your region, otherwise you have to delete your workspace and redo it. So if you have your workspace created, you can write out a configuration file and can check in that configuration file in your Git repository so everyone can check that repo out and connect to your workspace from a config file. So no need to check in any credentials. And this is what you get, ml.azure.com. So you see it is an experience outside of the Azure portal. There is also an experience in the Azure portal. It works, but this is way nicer. You have a way better view of what is going on. So let's zoom into a few of the things you get when you have this workspace. We're especially going to look at assets. So first of all, we have datasets. These are our place where we register our datasets. Experiments. Here we keep track of our trading runs. There are models. This is the model management part I was talking about. When our trading run is done and we're happy, we register our model there so everyone else can pick it out and use it. And there are endpoints. There are real-time endpoints. Here, this is the place where our deployed models live. And we have pipeline endpoints. This is where our published trading workflows are. We will dive in trading workflows a little bit later. There's compute. Here we manage our different types of compute. And then there are data stores where we manage the actual connection to our data. So later on in our Python code, we only have to reference a data store or data set and don't use any credentials. Second thing you need when you have your workspace is compute to actually train your machine learning model. And with this code here, I create an Azure Machine Learning compute cluster consisting of standard NC6 machines with minimum node 1, maximum node 6. Meaning that there is always one node up and running, billing my credit card. If you put it to 0, they will automatically shut down. And I can spin up a maximum of 6 nodes for concurrent jobs. And my virtual machine size is standard NC6. And that means this is a CPU enabled. This is a virtual machine with a GPU enabled that is optimized for compute, the C. And then we need storage because our data has to be somewhere. The data set needs to be somewhere on this, needs to be accessible for our training algorithm. So let's have a look. And I almost forgot that we have to kick off a build so that in like 20 minutes, our build is actually ready. So what we're going to do first is I will zoom in a little bit. I should be able to do that. Yeah, I think you should see it a little bit better now. So what I'm going to do, I'm going to change just a tag to Code PaLOusa 2020. We are going to see the change here. This is the change. Commit this one. Did I do that? Stage changes, commit, and then we set commit message. Change conference tag to Code PaLOusa. Confirm, and then don't forget to push the change. So now in the background, a DevOps pipeline will go off. We'll start training and we'll start deploying our model. That takes around 20 minutes, so we should be it should be done, or at least we should see it working while we're here. So what we can do now is also quickly take a look at Azure Machine Learning to our workspace here. And you see here I have my compute up and running. I have 4 types of compute here. This is my computer that runs Jupyter notebooks. It is now stopped. Then here are my training clusters. We have Optimus Prime, that is 2 nodes up and running. So this is billing double my credit card for these machines. These machines are around 600-700 euros. So you want to shut them down, and I will do that after this presentation. These are my clusters this is the cluster where my model will going to run in. Here we see our data store, and here is our data set, the Lego Simpsons. We will not dive in too much how data sets actually work at this moment. And here are our experiments. So let's kick off our Jupyter notebook, because we're going to build a pipeline. So step 1 is import a lot of dependencies. I always like to put them in the top cell, but that is up to your taste, of course. And this notebook is also available on my GitHub. So I've already have a workspace. I'm just saying workspace from config. I connect to my compute cluster. I connect to my default data store, and I connect to my Simpsons PyTorch pipeline experiment. And later on, it is time to start creating our pipeline. So if you have any questions, don't hesitate to just drop them in the chat. I'll give you like a second. So I want to make sure that everything is clear now. We have set up our Azure Machine Learning Service workspace in Azure, where we have access to compute and access to our data. And I have already uploaded the Simpsons dataset to a blob storage. I'm not going to show you how to upload to a blob storage, but the dataset is already there. So what we're going to do now is to create a machine learning service pipeline to deliver a model. You can first, you would of course experiment with your data on a very small data set to figure out if your model is working. When that is done, you're going to implement it in a machine learning pipeline so that later on you can create this process and kick it off from Azure DevOps. So let's talk a little bit about pipelines. What are pipelines? So we have Azure Machine Learning Service pipelines and we have Azure Pipelines. And both are completely different things, but they work together quite well. So Azure Machine Learning Service pipelines are workflows of steps that can use data sources, data sets, and run on compute targets. And they're very good for unattended runs and creating a reusable training process. They're good for tracking and versioning. While Azure pipelines are there to orchestrate things for continuous integration and for continuous delivery. They can set up gates, tasks, and other processes for quality, integrate with other services, trigger on code and non-code events. So if we want to retrain our model every night, we would have an Azure pipeline that kicks off an Azure Machine Learning Service pipeline. And that will deliver a new model. So let's have a look at the smallest thing in an Azure pipeline. So the pipeline is long, and this is one step. So a pipeline step runs a script, in our case a Python script, on a compute target in a Docker container. It has input, so data comes in, data goes out, output, and we can give it parameters. So we can configure how the script runs on that compute target in that Docker container. And combining these pipeline steps, so passing on the data from step to step, will create a pipeline. So we start with a data set of Simpson images on our blob storage. The first step will be there to prepare our data. It needs to be shaped and versioned. Then we pre-process, and then that step delivers us a pre-processed data set, which our model can pick up with a PyTorch estimator. With a PyTorch estimator. So train our model on the processed data and delivers us a model. Then it ends up in the latest step where it will register the model and delivers that model in model management for us. So what is this training file I'm referring to? So this training file can be anything. I got mine for the PyTorch website with a default example how to do transfer learning. Pick it up, put in a few adjustments, add some logging, but that's it. And save the outputs, of course, in a very specific way. I'll show you later. And when you have that training file, you have to wrap that in an estimator. So we create an estimator. And basically we say, we give us a TensorFlow, give us a PyTorch estimator. And we tell it, you can find our training scripts here. These are the parameters. Here we see that I'm just linking to where it can find the data, run it on this compute cluster. The entry script, execute this train.py, use a GPU-enabled cluster, install some other packages like scikit-learn, OpenCV here, but basically we don't need these ones when we're doing PyTorch. And we were using PyTorch 1.3 for our demo. And then when we have this estimator, so these estimators are run by themselves. They can run without the pipeline. So here you can test them quickly and see how they work. But when we start using them in Azure in a pipeline, we have to wrap it into an estimator step. So this step is called the train on GPU step. And we say, create a new estimator step, give it a name, tell it which estimator it has to run, so the previous created estimator here. Tell it where it can find the training data. So this is the data that is passed on from the previous step. And we tell it where to output our model. Tell it on which compute cluster it has to run, and we can parse some additional estimator script parameters to it. So when we have that, we have these multiple steps. We will look at how the other steps a little bit later. We create an array from them, prepare, train, and register. There are 3 steps, and we register that pipeline. We create a new pipeline. So we create a new pipeline, and we publish that pipeline. So when the pipeline is published, it is visible in the interface. We can click on it, see what it is, and then we can actually publish or actually submit this pipeline, and then it will start running. And then it will look like this. We will here have the details from the pipeline, and here we will see that it's starting to run all these individual steps one after each other. We see how long it takes, on which cluster it runs, and which type of step it is. So let's go to the demo and go through the pipelines, how we are going to create it. So the first thing I didn't show you yet is that I made a parameter for the input dataset. So my pipeline is getting, when it's kicked off, it needs an extra parameter that will tell us where it can find the dataset. So here, this makes it easy to switch datasets without changing the pipeline. So we do that here. We will tell it where it can find our script. We tell it the name of the model it has to deliver, and we tell it under which experiment it has to run. So let's run that. Then we create our first training step, and that is it's creating some new pipeline data location. So this is where it will deliver the data set. And here we see that it is taking as input the source pipeline parameter. So that is the variable data set. Tell it which training script it has to execute, or which script. It's not a training script here, it's the pre-processed data script, which compute cluster it has to run, and where it can find these scripts. So it can find these scripts actually here in this directory. So here's the prep script. import Azure ML, import some other dependencies, parse some incoming arguments, the source path and the destination path. And the only thing this script does for demonstration purposes is copy the source to the destination, and then it is done. So let's create this step. Then the train the model script is there. So here we see that I'm creating the estimator. These are the input parameters, like where it can find the data and where it has to put it. This is the output location for the produced model, the model location. So here we have the estimator step. There's a name, the references to the estimator here. The input, that is the output from the previous step. And then there is the output, that's the output we're creating here, and we're going to pass on to this step. Which cluster it has to run, and here we parse the parameters that will be parsed to the estimator eventually. So we create that. We can also have a look at that training script. So we see that here, train. So this script comes from the PyTorch website. I just downloaded it here, but I added a few things. So I've added a reference so that I will be able to parse incoming arguments and that I can connect to my Azure Machine Learning run context. And here I'm grabbing that context, putting it in this variable. I'll parse the incoming arguments, and then the script will continue as it was. Splitting the dataset, training the model, and here we go in the training function. And here we loop to all the number of training rounds we have to do. And in those training rounds, I added this. Here it says run, so our run context, log, under this name, so the training loss or the validation loss, and log this float. Because it is under the same name, Azure Machine Learning understands that it has to create a graph from this data for you. So we will see that when the training is done, how that looks. And the last thing you have to do is make sure you save your model in the outputs folder so that it is actually saved, because I said these estimators run in Docker containers and deployed on your cluster. So when your Docker container is done, it shuts down. And if you wouldn't have saved it in the outputs folder that is copied over back to your experiment, you would lose your model. And that can be a really big waste. So let's go back here. We create and register the model, and then we can create a pipeline. So the first thing I do is define the different pipeline steps. 1, 2, 3. Create a pipeline in this workspace. Validate it if it is actually working correctly. So we validate it. The steps are already created, so it will reuse it now. And then I can publish this pipeline under the name Simpson's PyTorch pipeline, training pipeline from our Jupyter notebook. So we do that. And then we can see that it is created here, created this step, created this step, created this step. And now we can actually submit that. So let me copy this so we can dive in that a little bit later. And submit this estimator or submit this pipeline. It will start now. It will publish the pipeline, it will build it. It will build all these 3 different Docker containers, deploys those Docker containers to our clusters. And when the first one is actually running and started, it will start showing log files here. So we will give it a minute, and otherwise we can always connect to a previous run that I did like a few hours ago, because you will always see that it will not, luckily it is actually running. So let's have a look at what is actually happening now underwater when we said submit this pipeline or run this pipeline. It first snapshotted our experiment with all our script steps in it and submitted that to the experiment. And then in that experiment, it created all those different runs For all those different runs, for all those different steps, I mean, it created separate Docker containers and deployed those Docker containers to our compute cluster. Mounted where all our data stores that we connected, so input, output data, it mounted all those devices, all those locations, and then launching the script like prep.py, train.py, deploy.py. And then it started streaming all the output back to the experiment. So that is always there. And we used in our Jupyter Notebook a widget that can connect to the experiment and grab make it visible what is going on. And when that is done with the individual steps, it copies off the output to the run in the experiment. So let's see how our model is doing. Yeah, I was not expecting that it would be any faster. So here we see that I have two nodes up and running. One is idle and one is actually running. That is good because that means that our other run for our Azure DevOps pipeline is done. So this one is running now. So we can ask it from the previous one, and why wouldn't it do that? List index is out of range. Did I copy that wrong? I probably copied that name wrong. That is horrible. Run.show. Okay. Let's not start struggling on here and just go to the interface here. So we go to the experiments. We were running our experiment we are running our iteration of the model in the experiment Simpson pipeline notebook. You can click on that. Here we see that run 9 is actually running for the last 2 minutes. So we go back to run 5, which was completed like a few hours ago in my morning. So here we see that it went through the whole process, had our data variable from our workspace Simpson Lego v3 as input. It pre-processed it. Here we can see all the scripts, all the different text. Here we can see which output it generated. See all the logs from the step. Azure Machine Learning, our Simpsons training data thing is here. You see our metrics. There are no metrics here. But if we look at the training estimator step, if we go to metrics, here we see how our model evolved. This was actually the run.log file. It resulted in this if we go to the training estimator step, which is pretty cool because here we see that our accuracy of the model against our test set is doing actually quite well. And then the last step, register to model. Here you can see all the individual steps. This is where the other runs remain 6, 8, 7. You can here we see the outputs of the whole run. So every single step has outputs, but also the whole pipeline can have output. So the pipeline is a run, and then you have child runs. So we can actually see that here there is a checkbox includes child runs, and here you see that it is Azure run type and Azure ML step run or pipeline run. So this one will be running for a little bit. You can find the model from the previous one back. Here is the one from Simpson's notebook. Here is our one with the Code PaLOusa, the one we just did. We will dive into that in a minute. So we will find, this is the model that is delivered. You can go back to your runs, see what it has delivered, and go back actually to your data from here. So Azure Machine Learning pipeline, you've seen what it can do. It is a repeatable process to deliver a machine learning model. It can do data preparation, it can do the training, and it can register our model. So that is the thing you can kick off from Azure DevOps. Like I said, I want to talk about DevOps or AI DevOps. So this was just in a Jupyter notebook, and no one is going to do that like every night, kick off a new pipeline like that. So that is where continuous integration comes in. And where we're going to talk about source control. So we want to set up source control, but we don't want to check in Jupyter notebooks. We want to check in every individual part of the pipeline, so we can trace if something changes, like in the deploy step or in the training step. We want to version that. We also want to probably include some infrastructure dependencies, like the YAML files for creating the pipelines, and maybe a small subset on the data to actually test it on. So everything we do for this should be a source control, except your large training dataset, because you don't want to check in a few gigabytes of images or even more in a GitHub repository. That is horrible. Don't do that. But it has to be a known, shared, backed up versioned data point, of course. So let's have a look at continuous integration. Why do we want that? Continuous integration can trigger on code changes. So you saw me changing the conference tag. That triggered a code change that would regenerate my pipeline and kick it off. Exactly like it says on the screen. Refresh and execute the pipeline. But before it creates the pipeline, we can actually kick off unit tests on that specific piece of code. Check for code quality, do some linting, and so on. We can even set up a pull request process. So let's have a look how we can set up a pipeline for Azure Machine Learning service. Let's go back to Visual Studio Code, because everything starts in Visual Studio Code. So you saw me having this Jupyter notebook. You can actually run Jupyter notebooks in Visual Studio Code, but that is not what I wanted. So we've seen this Jupyter notebook which creates all the steps. So what I did is I put that in a setup pipeline, Python file. So now everything is nicely in a code file, which we can check in and see the different types of, easily see the changes in it. So we start with some variables. This will log everything under the experiment as a pipeline DevOps. That's also will run on Optimus Prime. Then the model name that it will deliver is Simpson's PyTorch DevOps. Pass some incoming arguments, which we don't need. Connecting also to my workspace, compute targets, experiment. And then we start defining the pipeline. And also creating this variable, exactly the same as in the Jupyter notebook. Creating the pre-process step from the same Python file. And it's creating the estimator here with the training script and registering the model script. It's creating the pipeline, it's publishing the pipeline, and it is submitting the pipeline. So it starts running. So I just check that one in. And then I've created an Azure Pipeline YAML file. And the only thing that file is doing is installing or upgrading the Azure ML SDK on a Ubuntu latest virtual machine image, and it triggers on any change on the master, sets the Python file, installs the package, and runs the setup pipeline on any code change. So also, if something is changed in one of these three steps, it is triggered. And here we go. So let's have a look how that was in Azure DevOps, because we just go on and refresh. Change here, we see our latest commit, change conference tag to Code PaLOusa. You can click on that. Don't want to go to here. I just want to go here and see my job. So here we see it checked out our repository, set the Python version. It installed this Azure ML SDK, run the CLI, started creating. So you see here it is created the pipeline. You can click on this link to actually see the pipeline in Azure Machine Learning. It's pretty cool that you can click from the logs to this pipeline. Here we see the run. This one is logged. It is exactly the same code So here we will also see on the metrics the accuracy improving. We see also the same output that is delivered as the deployment scripts and our labels. And here is our model with all the log files. Here, the graph, exactly the same. And then it did these 2 steps and finalized the jobs. So now we have set up continuous deployment of continuous integration for this part that delivers the model to model management. And here we see that our model is actually delivered from Azure DevOps with the tag Code PaLOUsa. And also our run in the notebook is finished, giving us, okay, I'm clicking a little bit too fast. Sorry for that. Let's go to models. So here we see also this is the model that is just delivered by us by our new latest run from our pipeline, from our Jupyter notebook. But I want to check in here, version 3. So here we see that it's generated by this run, our tag, when it was, this is the time for me, that is like 20 minutes ago. That went fast, and our artifacts are here. So now everyone that has, of course, the appropriate permissions can pick out this model and start working there. So that brings us to the latest part of the presentation, and it is about picking up the model and deploying and running it in a production environment. So you can use Azure Machine Learning Service to do that for us and to create the software around it. So the only thing we need is the model, of course, the script that will load in the model and writes the software around it and returns something so we can do it, like it's called a scoring script. And we need a file that defines the environment where this model has to run in. Wrap those 3 up in a Docker image, give us the Docker image, and we can deploy it wherever we want. So we can deploy it using Azure Machine Learning Service. So we can create a new deployment. We pick and deploys it to an Azure container instance, can deploy it out of the box to an Azure Kubernetes service for us. But the Docker images that's created is also available in our Azure Container Registry. So we can easily create a build process that triggers on the creation of that Docker image and just deploys it like you would deploy any other Docker container. But it can help you, this Azure Machine Learning Service can help you to deploy it for dev or test very quickly so you can see your API is actually doing something. So yeah, there must be a better way to actually do it instead of from only code. So the developer, we have looked at it, delivers us a container. And we can create this software ourselves. So I'm not going to show you how to do that, but you can create software around that model from scratch. You don't need Azure Machine Learning for it. You can now start writing it out yourself. So you can have an application.py, Docker configuration file requirements. You can check in your Azure Machine Learning config that we created on the beginning of the presentation. And then we can create a script that will just download the latest version of the model for us on build. So what we can do is our developer can create this build pipeline and just build software like it would, run the script to connect to model management and pick this model up for us. So I can show you that, but I actually want to show you something a little bit different to make your life that will make your life a little bit easier. So what I've done here is I've created a release pipeline. So there is an extension for Azure DevOps where you can create a deployment trigger based on the delivery of a new model in model management. So let's dive here. We see that this is our model, 5:30, 20 minutes ago, release 8, that is deployed, triggered on version 3 of our model. So let's click on that. Let's see what it is done. So I've set up continuous deployment and triggered on Simpson's Python DevOps model version 3. on this artifact because it is an artifact, and it kicked off his deployment pipeline. And what I've done is, can I edit it? Yeah, let's edit the pipeline. So here it triggered, and here we went into this state. So when it triggered, I just used Azure CLI to do a few things for me. I said, download this model for me, please. Within the model, I've already have this environment file that will specify how the environment should look. I have an inference config that will tell me to look for this environment file, for this scoring file, and that it has to be a Python image. And here is the scoring file. And the only thing the scoring file does is load in the model, handle input data, run it through the model, process the input data, run it through the model, and return the result. Only thing the scoring does. So we have the deployment config that will specify the type of Azure Container Instance, CPUs, memories, no authentication, no SSL, no application insiders, as basic as it is. And I wrap this within my model. I'm downloading these files, and then I can use Azure Machine Learning Model Deploy, this task, to just deploy this model for me, specifying under deployment instance, deploy it to this ACI and to this deployment config. And that's basically what you have to do. And this is the inference config. So, and it triggers on this model artifact. And then it can deploy it for you to an Azure Container Instance. And the cool thing now is that I can go to this model, go to model tree, go to endpoints, and we'll find where this model is deployed, because this is the part you're missing if you're going to do it yourself. If you use Azure Machine Learning service to deploy it for you, it will link it here. So I can click on this. So I can click here and can find my scoring endpoint. So I'll copy this endpoint. It is a brand new endpoint, and I can paste that here and send a test image of Krusty to it. So here we have Krusty the Clown. Can send it to it, and it says, hey, I'm 99% sure that this is Krusty. And to show you that it is actually working, I can change it to Bart. And now we see that this endpoint is actually saying it is 89% sure, 98, sorry, percent sure that it is Bart Simpson. So I think that is pretty cool, because we just deployed a working model within 50 minutes using Azure DevOps pipelines, made the process traceable, figured out how we could work together. It is backed by GitHub, so everything is versioned. We have Azure DevOps, we have controlled and versioned datasets. So everything a team should need. So let's recap. We have a data scientist using Azure Machine Learning, controlled by Azure DevOps pipeline to deliver as a model in model management. Our developer can connect to model management, pick it up, and build a pipeline for it, deliver as a container, and operations can pick that container up and deploy it actually to an Azure Kubernetes service, ACI, whatever you want. And then our client can send requests to this API. So that was it for me, what I wanted to show you. So if you have any questions, this would be the moment to ask them. If there are no further questions, I want to invite you to go to my GitHub. This code is actually there. You can do it. You can retrain your model, set up the pipeline, look at the code, see what I've exactly done. There's also my blog. There are more starting tutorials on how to get started with Azure Machine Learning, how to set it up, how to build a model without the whole pipeline thing. And if you have any questions, you can always go to my GitHub, and create an issue, of course, or you can go to Twitter, send me a DM, and I will answer, or send me an email on my Microsoft email address, henk.boelman@microsoft.com. So So thank you everyone for your attention and enjoy the rest of your virtual conference.